Okay, so here it has been asked to minimize the objective function. So here the objective function is, here the objective function z is 3x plus 5y, and the constraints are, x plus 3y that is greater than or equal to 3, and x plus y that is greater than or equal to 2, and x comma y is greater than or equal to 0. So this inequality represents the first quadrant. It represents the first quadrant only. So therefore here we need to draw the approximate graphs of these straight lines, which are x plus 3y equals to 3 and x plus y equals to 2. So x plus 3y equal to 3, it will intersect the x-axis at 3, 0 and the y-axis at 0, 1, and it will intersect the x-axis at 2, 0 and the y-axis at 0, 2. Okay, so here, so let's draw. So this is the y-axis, this is the x-axis, and this point is suppose 1, this point is 2, this point is 3, this is 0, so it is 1, 2, and this is 3. So this point is 0, 3, this is 0, 2, this is 0, 1, this is 1, 0, this is 2, 0, this is 3, 0. So this straight line passes through the point 3, 0 and 0, 1. So it will be somewhat like this. Equation of this line would be x plus 3y equal to 3. And this straight line passes through 2, 0 and 0, 2. So it would be somewhat like this. So it will pass through the point. It will. The equation of this straight line is x plus y equal to 2. So here we know the point A. We have to find the coordinates of the point B, and so this point origin is 0, 0. So this inequality will not satisfy the origin, and this inequality also will not satisfy the origin. It means both regions will lie away from the origin. Means for this line also it will be away from the origin, and for this line also the solution region is away from the origin. So we need to take the common region, will be the feasible region. So the feasible region will be this one. So this region will be the required feasible region. So we can tell, suppose this is point P, this is point C, this is point Q, suppose. So therefore here the region PABCQ is the required feasible region. This is the required feasible region, and we can see that this region is unbounded. It is an unbounded feasible region. Since why this region will extend towards to infinity, and it cannot be enclosed within a circle, and therefore the point A, that is 0, 2, and we need to use the corner points. So A is 0, 2, and point B, how to find it, is the point of intersection of the lines x plus y equal to 2 and the line x plus 3y equal to 3. So from here we can tell x equal to 2 minus y. So if we put that here, we will get 2 minus y plus 3y equal to 3. Then 2 plus 2y equal to 3. Then it means 2y equal to 1. So y equal to 1 by 2. So y is equal to 1 by 2. It means x will be equal to 2 minus 1 by 2. That is equal to 3 by 2. So therefore the point B is 3 by 2 comma 1 by 2. Point B, it is 3 by 2 comma 1 by 2. And the point C we know. Okay. So now here we need to find the value of z at the corner points. So corner points, and we need to find the corresponding value of the objective function z. Objective function z, which is equal to 3x plus 5y. So now here the corner points are A, which is 0, 2, and point B, which is 3 by 2, 1 by 2, and point C, which is 3, 0. Okay, so therefore the value of z at point A, it will be 3 into 0 plus 5 into 2, so that is 10. And at the point B, that is 3 into 3 by 2 plus 5 into 1 by 2, so that is 9 by 2 plus 5 by 2, so that is 14 by 2, that is 7. And for the point C, that is z will be equal to 3 into 3 plus 5 into 0, so that is 9. So here it is asked to minimize the value of z. So now here, since the feasible region is unbounded and the minimum value of z according to the corner point, it is coming 7. So since the feasible region, since here the feasible region is unbounded, so we also need to consider the inequality. We also need to consider the inequality which is given as the inequality which will be z is less than 7. That also we need to consider. It means we need to consider 3x plus 5y is less than 7. So we need to draw the solution region of this inequality also. So now 3x plus 5y equals to 7. We need to consider this straight line. So since it is less than 7 means no, it means that all points on this straight line will not be a solution of this inequality. So we need to draw a dotted line. Here we need to draw a dotted line. Okay, so um, so now it will intersect at the point 7 by 3 comma 0, and the y-axis at the point 0 comma 7 by 5. So 7 by 3 comma 0, it means it is somewhat 3 to just 6, 2 whole 1 by 3 comma 0, and the y-axis at 0 comma 5, 1s of 5, 1, 1.4 actually. So we can say it is 2.33, 2.33 comma 0. It would be somewhere somewhat slightly here. It is slightly less than half. So at point 7 by 3 comma 0, it will intersect, and at the point 0 comma 1.4, so 1.4 would be somewhat slightly less than 1.5, so it is 0 comma 1.4. And at the point 3 by 2 comma 1 by 2, if we put it here, then 3 into 3 by 2 plus 5 into 1 by 2, so that will be 9 by 2 plus 5 by 2, so that is 14 by 2, that is 7. Yeah, so it means that 3 by 2 comma 1 by 2 will satisfy this line, will satisfy this line. So we need to draw one dotted line which will pass through these 3 points. So the equation of this line is 3x plus 5y equal to 7. So here we can see that 3x plus 5y is less than 7. So it means in this region, since y here origin will satisfy this inequality. So here we can see that there is no point in the solution region of this inequality, which is 3x plus 5y is less than 7. There is no point in common with the solution region of this with the feasible region of this. So hence the minimum value will occur at the corner point B only. So here we can see that the solution region of the inequality, which is 3x plus 5y is less than 7, has no point in common with the feasible region. No point in common with the feasible region. So no point in common with the feasible region. So the minimum value of the objective function, z is 7 only, which occurs at the point, corner point, which is 3 by 2, 1 by 2. So this is the final answer. Thank you.